Question in front of us right now is true root 3 is an irrational number. So we need to show that root 3 happens to be an irrational number, and we're going to be doing it with the help of the textbook method, something called as method of contradiction. What we do is we assume that it's rational. We go other way around. Okay, when I say to show it's a irrational number, start off by saying that let's assume it's rational. So we'll start with the first statement. Assume root 3 is a rational number. We are doing it on purpose because this method itself is called as method of contradiction. So if it's a rational number, we know that we can write it in the form of P by Q. And P and Q are technically integers. We mentioned that also, where P comma Q are integers and Q should not be equal to 0. The denominator cannot be equal to 0. Why? Because if we show that it is 0, then any number by 0 will be undefined. So we have to make sure denominator is not going to be 0 and they are co-prime. This happens to be an important part of it. You have to understand co-prime meaning. So co-prime, what does it mean is, suppose you are having a number, say 25 by 30. 25 or 30, can they be reduced further? Of course, they both of them come in pi tables. So these numbers are not co-prime numbers because they have a common factor. Because they're having common factor, we cannot reduce them we can reduce them further. So we can reduce it and write it as 5 by 6. Now this 5 by 6, do they have any common factor with us? No, we do not have any common factor. Hence, we can say that they are co-prime numbers. They do not have any common factor. Similarly, here we're thinking and writing root 3 is equal to P by Q, and P and Q are co-prime. And if you do not write this word co-prime, you will be in trouble because this is where the whole question is revolving around. Okay, our answer is revolving around that same point, co-prime. Okay, so we are assuming that P and Q are co-primes. It means it do not have any common factor. So HCF of theirs is technically 1. So that's going to be a first part. And now comes our working. So we will equate it to P by Q and we'll cross multiply now. So when I cross multiply, so I get root 3Q is equal to P and I square on both the sides. By squaring on both sides, I end up getting 3Q square is equal to P square. Now this is a little bit more thoughtful. How do you do it? 3Q square is equal to P square. I'll tell you logic over here. The logic here is, let's say you're multiplying a number 3 with some other number and you're getting an answer. So we can say that the actual answer, for example, we'll take 3 into some number, let's say 16. What will 3 into 16 be? 16 3 I think 48. 16 30 to 48. Okay. So here clearly you can see that 48 is divisible by 3 tables, right? So that's what the point will be over here. So in this case, we'll do the same thing, that because 3 times a number is some number, so you can say that P square is divisible by 3. Now, if you take a square number which is divisible by 3, then obviously square root of it also will be divisible by 3. For example, 81. Now 81 is a perfect square, right? So 81 is divisible by 3, then square root of it, 9, also will be divisible by 3. So that's the same logic we will say. If the number p square, which you do not know what it is, if the square of a number is divisible by 3, then p is also divisible by 3. This is how you end up the first part of it. It's pretty simple, but unless you understand logic behind it, you will not be able to get the answer. First, we start off by assumption. Root 3 is equal to P by Q. Our P and Q are both are integers and they are co-primes. And then we get them, we square on both the sides. We end up getting 3Q square is equal to P square. And then the statement comes P square is divisible by 3. P is divisible by 2. Okay. And now the second part. Now, second part here involves to bring another number in there, another constant in there. Let's call it as C. Okay, let us take P is equal to whatever times the number over there, no? Over here, 3, right? So we'll take P is equal to 3 times C. And what is C here? We'll tell that let C be any integer such that P is equal to 3 times C. So the number P, what we're taking, it should be equal to 3 times C. This is the way of doing the method of contradiction. So when we are establishing another constant C, which is a number technically, right? C is a number. So what number, what time it is? That is 3 times the value will be giving us P. Now again, same thing, we'll square on both the sides by squaring on both sides. So we get P squared is equal to 3C whole square. So we get P squared is equal to 9C square. But from earlier version, you can see that P square can be written as 3Q square, no? So that part will write P square as 3Q square. We'll put it over here. We'll replace this. So we will say 3Q square is equal to 9C square. So again, when divide both sides by 3, we get Q square is equal to 3C square. And the same statement what we got in the previous part will write over here because Q square is written as 3 times some number, right? So Q square is divisible by 3. So if the square number is divisible by 3, as you know, the Q is also divisible by 3. Now this is where we have to put our conclusion. So as both P and Q are divisible by 3, it contradicts our assumption root 3 is contrary our original, contrary to our assumption that they are co-prime, that they are co-prime. Hence, root 3 is irrational. So when we started, we showed that they did not have any co-prime. We had taken the numbers in such a way that they had in reduced form. They did not have any common factors here. So that's why we started on that basis. But when we come to an end, when we came to end, by that time we figured out both P is divisible by 3, Q is divisible by 3. And this comes to an contradiction that they are co-prime. So hence the co-prime word is pretty important for expressing it down, explaining the whole process. At that last part, you have explained very clearly as the assumption here that what the co-prime we had taken is not coming out to be true. Hence, it is our assumption is wrong, and therefore the given number root 3 is irrational number. This is how we show proving of an irrational number. Slightly confusing, you can say, but when you do the same thing with different numbers, instead of root 3, you can try with root 5 or root 6. You can only do it for imperfect squares. You cannot take root 4 and because root 4, we know that it is basically plus or minus 2, right? Not for that. The numbers which are not a perfect square or not perfect cube is what, but we only have it in square root. So sticking out to that level. So that is the way of doing it. Okay, with that, we'll stop.